Welcome back to the shop, and today we're going to be continuing on our little prop build project, and we're going to be cutting our foam today. If you watched the last video, you can see I had a utter failure kind of cutting this out, and so we did some research and went online and came up with a homemade hot wire foam cutter, and it actually works pretty good. So we're just going to do a quick overview with it. We're not going to go through the build process. It's relatively simple. Everything I had lying around down here. The only thing I had to buy was the dimmer switch. Everything else, well, dimmer switch and a spring is basically what I had to buy. Everything else I had on hand. The transformer you might not have on hand, but that came out of an old rooftop unit. So I had that in stock on my truck. We just used that. So let's take a peek at what it looks like and how it works. Okay, so this is it. Basically this is the 1/8 inch oak ply that I had left. 2x4s, kind of make a little swing arm here. A wire, which we'll get into what that is. We have up here is a 24 volt, well 120 to 24 volt AC transformer. It's 75 VA. That's kind of important. Is the higher the VA, the more amperage that this is allowed to put out. Now, to get convert VA into amperage, you take the output voltage, which is 24, and divide it by the VA, which is 75. So we get a little over 3 amps, 3.1 something. And this also, I'm just panning you up a little bit here. I know you probably can't see it, but right here there's a built-in resettable 3.2 amp fuse. Now on the back here, we have one leg of our 24 volts going to this bolt here that's captured, and between these two washers here there's a spring to allow tension on the line. And that bolt goes all the way through and is attached to our wire. There's on the back here these extra wires are just because it's a universal transformer, so it does up to 460 volt. It's wired for 120 input. Right here is a light dimmer switch. Now technically this shouldn't work. Let me grab the paperwork for it real quick. Technically this shouldn't work. This is for incandescent lights, so this is for a purely resistive load, not an inductive load, which this is. So technically this shouldn't work, but it actually does. What you would really want is something that can do an inductive load, like a motor speed controller or a dimmer that can do low voltage lighting, like low voltage track lighting, something that's built to vary a transformer. Now this is incandescent only, and it works. It works fine. Technically it shouldn't. Technically it should burn out, but I'm not having an issue with it. And the one that I used, and the reason why I got this is because it was only $5. I figured if I blow it up, I'm only wasting $5. The other ones for inductive loads and track lighting and stuff, you $25 to $35 for those. So the one that I got is this one right here, and you can see the part number at the bottom there. And like I said, it cost me $6 at a True Value Hardware. And it works perfectly fine. The other leg of the transformer, which is this green wire here, just goes into the base, and all that does is go to a lug on the bottom that this wire here is looped through. Now the wire itself, I had tried using a guitar string wire, and it worked fine. The only thing was it had a lot of flex in it. And when I tensioned it up to where I wanted it, when I heated it up, it broke. So I asked some people online, and thank you guys for Facebook, and everybody said that you needed nichrome or some sort of resistive wire, and to also pop a spring up on the top so that when this heats up and it expands, this spring here will pop up and pull it tight. Now this is a resistive wire, and Some people offered to send me some, and you can get it online for cheap. But I'm impatient, and I wanted to get everything done this weekend, or start doing this weekend. So I was thinking of what kind of resistive wires I can use, you know, what is made to heat up, and I found something. Alright, so what this wire here is one of these coils from an old crappy hairdryer. Now this is a hairdryer I had lying around since I moved in. I actually use this to help heat up the vinyl tiles when I did the floor. So I was never going to use it again, and it's a piece of junk, and it's just been sitting here. I think it's cost me a whole $10. And so I broke it open, and you can see we got two different sizes of wires. We got a smaller one here and the larger one. This larger one's 21 thousandths. This one at the bottom here is probably somewhere around 15 thousandths. And one full loop of this gave me enough to do 2 wires. So from here around to here. So one full wrap. Oh, sorry, one full wrap. Gave me enough wire to do 2, so I have enough to do 1, 2, 3, 4, 5. So I have enough to do 10 more wires of the larger stuff, and probably 4 of the smaller wire, and it works great. And the other good thing too is we have a little cooling fan that we can salvage, a little 120 volt cooling fan we can salvage for something, and we also have a GFI'd plug that we can salvage for something. So with some experimenting and everything, this is a push button on and off switch, and it also varies the voltage going to the transformer, which would vary the voltage out, which varies the heat on this. So I got it adjusted to where I want it, and it was just trial and error. So I'm going to get you probably a better view here, and we'll go cut this foam. Here we go. Alright, didn't come out too bad. And all this will be smoothed down with some sandpaper and a block. And each one of these faces is vertical, so that's why it looks choppy when you look at it from the side. Each one is a flat face all the way around. So we'll straighten this out, get this all even, and then we'll start doing the detail work around the outside edge. Okay, so now let me just show you on the other plans here. We're going to start doing the detail work around the outside. So all of these are the same except for this one. And then there's a bigger piece here, but those are added on top of the 1/8 inch pieces that we're going to be cutting. And we're going to be using 1/8 inch birch ply. And we're going to have 13 of them, all the same size. And they're going to be 1.6 inches wide and 2.5 inches long. So I got this set up at 1.6. The fence, we're just going to rip a piece off of here, and then we're going to start chopping it into 2.5 inch pieces. I'll measure it out. I have 24 inches, and we need 13 of them, so I'm not going to be able to make them all out of one. So we'll take 2 swipes, and then we'll start nipping them away. Okay, just got you over here on the table saw because when I put it on my workbench, the white paper kind of blows out the exposure. So we have everything all nice and sanded. You can still see that we got flats on the side because each one of these is actually a flat. So we're squared away with that. Now, what we needed to do is make these little pieces that go around the side. Now, I had already cut them all. I skipped most of the cutting process because, you know, it's boring. Everybody's seen wood cut. But the measurements on these, on the plans here, is 2.5 inches tall by 1.547. I did mine around 1.6 or so, and we came out okay. Basically, which you don't want them to touch, more or less. You want them to be spread out. Not crowded. So there are 13 of those all the way around the perimeter. There's one exception. This one here is smaller, which on the plans is this here, and that is only that sits up a 1/2 inch, so that's actually only 2 inches tall. And also this here, which is a 1/2 inch block popping off the edge, is this here on the plans. That's the same size as the other ones here, or a little bit shorter actually. That's only 2 inches tall instead of 2.5 inches tall, and it has 2 holes drilled into the side, 2/4 inch holes, one at 1 inch up from the bottom and one at 1 inch 5/8 up from the bottom. And what those will have is pneumatic fittings that hoses are going to hook into. Also, this one has a hole in it, and this one here has a hole in it. So we have our, basically, there's our stack of 13. Here's the ones with the hole in it. Here is that one with the 2 holes drilled into the side. Here's the shorter one, and here's the full size 1/2 inch piece. Now, also what we need to do too is get these 2 round pieces, which in the plans are these 2 pieces that stick off the top. Now it's the larger one is an 1/8 inch piece on the bottom with a 1/2 inch piece on the top, and the smaller one is opposite with a 1/2 inch piece on the bottom and 1/8 inch piece on the top. The top piece is smaller than the bottom piece. So in the plans, this is this larger section here is 3.493. So what I got was a 3 5/8 drill bit, hole saw. It was able to drill a slug out of the 1/2 inch ply, and that fits in there perfectly. Actually, it would be this, and that fits in there perfectly. And I got a 3.5 inch hole saw to make a smaller piece, and that is going to go on top, but it's slightly too big. Same thing with this. I didn't have a hole saw big enough to give me, let's see what we're looking at for we're looking at 2 1/4 on the larger size and just under that 2 1/4 on the smaller size, I'm sorry, and 2.312 on the larger size. So basically just out to this outside edge. I'll measure that and get what my actual measurement is, and we'll make it to that. Now I couldn't, I got the smallest hole saw that I could, which was a 3-inch hole saw, and we cut a slug out of that. And as you can see, I put some studs in these. So what we're going to do is we're going to go on the lathe and we're going to grip this, and we're just going to turn it down to the size that we need. That way you don't have to buy a whole bunch of hole saws. You can just use what I have here. So what I'm also going to do is I'll stack these up. I'll get that in the perfect position, and then I'll take the drill bit and I'll put a hole straight through it, so we have a mounting stud. And I'll do that on both, so then we can take this off and peel this paper off, and then put these right on top, put that stud in place, and that'll be our alignment. So I can leave the paper on here as a jig and then peel it off when we're done. So let's actually set up on the lathe and start turning some wood down. Okay, so we got about a 1/2 inch to come off of this. I'll just speed up the lathe here, and I am using a carbide insert. Shouldn't, if I get a terry finish or it looks kind of like crap, I'll get a high-speed steel insert in here, but if I don't have to change out my tooling, all the better. So if you speed up the lathe, right? I don't have to take much off of here. I only have to take about 50 thousandths. Three and a quarter. Okay, this is the smaller one. We're looking for 2.312 on this. A little bit of run out. That's a little better. Okay, so I got the paper peeled off and I cut 2 of the heads off the bolts, and I'm going to epoxy those as studs in place. The one for the larger piece is going to be sunk below the surface because this is flat on top. We'll fill the divot later. The one on the back here is going to be proud of the surface by about ½ an inch or so, and the reason is because there's going to be a tube that goes on top of this, and what I can do is I can epoxy a bolt in the bottom of that tube once I get it all set up and just screw it in and hold it. The reason why I'm using studs in here is that way these are 2 pieces glued together. It gives me a little bit more strength, especially on the piece that's going to have a lot of leverage on it. And it also serves as an alignment pin to keep the 2 pieces aligned. And we're going to use 5-minute epoxy from Loctite, and I did a test on it. I did a test on another piece, and I don't seem to have any kind of issue with it melting the foam, so we're good with that. The rest of these pieces, I want a little bit more working time with it, so we're just going to be using the Loctite foam adhesive for those and screwing on. But these ones I'm going to epoxy right into place. So we're going to mix up a batch here, and we're going to get going with these. Okay. I'm gonna let that dry. Gonna go have something to eat. Come back and see what happened. Okay, so we let everything dry, and there it is. So these are in there nice and sturdy. We have the peg to screw the tube in place. There's all the outside rim, and she's gonna fit just about like that. Actually fits up pretty well. When I get this all glued in place, any little gaps here, those will be sealed up with probably some body filler or something like that, and sanded smooth just to get the blemishes out, and that'll look like one piece. Now the tube, what I'll probably end up using is a piece of either a piece of Delrin or a piece of PVC, whatever's easier to get my hands on. That correct size. It's 1.5 inches outside diameter. I have some 1 3/4 Delrin. I just don't want to turn the whole thing down, so maybe I'll just buy a little length of 1.5 inches or 1 1/4 inches rather, and use that. And that way I can just drill through the bottom, sink the screw in there, and we'll be able to drill the other end, because that's where a actual tube is going to go into it for the wand. So we can drill it and get a nice fit for that. So for the time being, this is going to be set aside, so we're done with this for now. Okay, so what we're going to be working on is this, which is our 9-inch cake pan, and I already had marked that out in the last video, so we're just going to drill the holes here. We got to make these flanges that are going to be glued over the top, and then we have to make this part here, and as you can see, it follows the profile of the pan here. The only difference between this and what's shown on the plans here is this flange on the edge, you can see, is nice and square, and it's 1/2 inch. This is rounded, just folded over, and it's only 3/8 of an inch thick. So what I may end up doing after the fact is I might just leave it alone, because there's not much of a difference in size, rather than trying to sculpt a piece. But what I will do is actually fill it in and square it off. So I might take some Bondo and we'll just go around the edge here, and we'll kind of just square it off and fill in that little groove in there, rather than trying to cut a ring and placing it and all that stuff. I think that'll look fine. And then we just have to fill in this the lettering in here. So let's get this out of here, and I think it's cost like $4 at Home Goods, and we go over to the little mobile workbench and we'll drill this out. Alright, just drilling the holes out in this plate, and we're using an 1 3/4 hole saw, and I had to put a new bit in there. This bit is actually too long for it, but I don't have another hole saw bit. The actual hole that you're going to be seeing inside the flange is going to be a little over 1 1/8 inches, and the actual little flange is going to be 2 3/8 of an inch. So we're drilling a bigger hole so we can mount the lens easier from inside. And yeah, I know I'm holding this by hand. I always get yelled at for that, but once it grabs, it's fine. And there it is. So those holes are cut, and we just got to make a flange to go over the top, and we'll glue those in place. We'll deburr the holes, and so we can start touching it, and that's it. Okay, we got it all deburred, and I sanded off that non-stick coating there, so that way there we can glue to this. It gives the metal some tooth, and we can also go with some self-etching primer when we're ready to paint and fill in this little little name here. As you can see, it's stamped in from the back. So, and now I'm envisioning that this is where most of my electronics are going to go, is between this and the piece that we just made. I'll hollow out the back of that. That'll give me a ton of room. This will probably house, it's obviously got to house blinking lights, but I figured this would be a good place to mount at least most of the controllers that are necessary to make the different lights flash, and then be able to feed the wires from here out, because everything else should be hidden. At least that's the plan. We'll figure that out once we get this done into sub-assemblies, how the electronics are actually going to go. But alright, so now what we have to do is make the little flanges that go over this. And like I said, they're going to be 1/8 inch thick, so I'm going to use that 1/8 inch ply that I have. And they're going to be, 2 3/8 of an inch. So what I'll do is I'll get my, my other hole saw. I'll put that on, we'll drill out 4 slugs, and then, it's the easiest way to do this. So I have to have a hole in the middle of them too, so. What we'll try to do, we'll see how this works. What I'll do is I'll drill out 4 slugs, and then we'll turn the OD down on the lathe, and then we'll see if we can kind of get them all scrunched up together and maybe drill a bore straight through them for the idea of that. Because I don't want to do a hole saw and then a hole saw unless I can come close with an internal hole saw. Then I won't have anything for the outside, the OD hole saw to grab. We'll figure something out. Let's get the OD of everything done first. Okay, so we got all 4 blanks together, and we got to go to 2 3/8. Alright, so now the inside of this has to be 1 1/8. I have to take that screw out of there. I wonder if I could hold that in the chuck and bore it out. That'd work. Okay, so now we need to make this piece right here, and it's a cylinder that rises from the bottom and cuts the contour of that plate. So it's 3 5/8 tall, so I have 2 2-inch pieces glued together. So we're going to have to take 3/8 off of that, and we have 2 3/4 inch diameter. So we'll set our little dividers here to to 1 inch and 3/8. So there's 1 inch and 3/8. And there's our circle to follow, and we can verify that we're 2 3/4. And actually it's easier to read this side. 2 3/4 on the money. Here we go. There it is there. Alright, I'm going to take 3/8 off of the edge here. What I might do is get a guide and just clamp it here and use it as a fence. Okay, so this here I just smoothed out, and that fits around the contour of the pan, and it fits off an angle off of this little circle here. So what I did is I measured from the bottom up here and marked that, and then I held this in the position that I wanted, and I traced along the bottom with a pencil to get the curvature of the pan and just brought those lines up. So I'm going to remove this chunk, and that should give us a pretty good fit. I might have to just cut around this just a little bit more because I measured from here up. So we'll just start whittling this away here. And that's right where we want to be. And what I'll do is when I glue this in, all these little edges here will be filled in with silicone, and you won't be able to see those. Basically, we're right, according to the plans, we're just about straight underneath it, or maybe a little bit to the right. So we're right within the realm of where we need to be. And we just gotta do some holes across the top. I'm gonna stop for tonight and clean up down here, and we'll do this on the next project. So let's kind of go over to the bigger bench and we'll put everything together and see what it looks like right now. Well, there it is, or most of it. Let's see if we can get that a little bit better of an angle, I guess. You can see we have the two pieces that we made. Those are glued on. Those ain't going anywhere. We got the stud to be able to screw the tube down. We have the little piece we just made, and also the top here. So, like I said, I have about 2 inches worth of room in here, plus 2.5 inches worth of room in here. So, or actually 2 3/4 inches worth of room in here. So we can actually cut out a good chunk inside here. We have plenty of room for electronics in here, because we're going to have blinky lights, and I'm hopefully going to have a sound module. You know, figure if we're going to do it, we're going to do it right. So I'm going to leave it as is for now, and then we'll start working on the other pieces. I'll see what I can do to get the tube in here. There's going to be a couple of pieces up here. There's going to be one more piece over here, and there's going to be like a connector from here to here, and then a few little things, a few little hoses and whatnot. So then we'll, you know, get this foam hardened a little bit, stiffen it up a little bit, and drill the holes in here and do all the finishing work. It's going to take some time, but you know, it's coming out better than I thought it was going to do so far. So I'm happy with it, and happy with the progress that we made so far. So next week, more than likely, I will have an actual machining video out for you guys, and we'll get that out to you. And you know, we'll just set this off to the side for the time being, and we'll definitely come back to this. So hope you enjoyed this video, and we'll see you on the next one.